Welcome to FOB TV, the future of business. I'm your host, Kevin Benedict. I'm a lecturer and futurist here on the team at TCS, and I want to thank everyone out there for joining the program today. Our guest I'm excited to introduce is PLN. Now, that's his abbreviation for his name, and that also stands for pretty long name. So we're going to go with PLN, but before we start, PLN, what does the acronym PLN stand for?
Yeah, hi, thanks, Kevin. Yeah, PLN is the shortest form of my name. It's the initials of my first name and last name, Pathasarathy Lakshminarayanan. So P from Pathasarathy, L Lakshmi and Narayan. Lakshminarayanan is my name and Pathasarathy is my last name.
And that's why we're calling him PLN.
Yeah.
So PLN, now you are the global head here at TCS of smart mobility and the Factory of the Future initiatives and Case Automotive at TCS. So again, thank you for being here. And we're going to have a fascinating discussion. But before we jump into that discussion, where are you calling in from today, PLN?
I'm in Troy, Michigan.
Detroit, Michigan. Yeah. Is it snowing? Is it warm? What's it like there?
Today it's okay, a little bit sunny. The snow is still melting. We had a big snowstorm, icy storm, in fact, over the weekend, and I think we are getting another storm tomorrow. So we are just letting this snow melt before the next one dumps.
All right. So wow, in your area of expertise there in Detroit, Michigan, around the smart factories and all that, man, the advancement, the amazingly rapid advancement of AI must be significantly impacting your area of responsibility. Tell us about that.
Yeah, so both from the mobility side, which is the vehicle, in-vehicle aspects of it, and the manufacturing, which is the factory, right? So I think generative AI, while AI is there, but Gen AI has taken it by storm, and we are seeing a fundamental shift, right? And when you talk about mobility, it's a lot about autonomous vehicle or electrification. Those are the two big convergence point that's happening, and both are being driven by generative AI in that sense, whether we accelerate safe autonomy or provide in-vehicle customer experience, what we call as hyper-personalized experiences to the customer who is driving the vehicle. In fact, nobody knows, can my vehicle do this, right? There is a lot of possibilities there. And when it comes to manufacturing, it's a lot more where we are talking about AI first approach in manufacturing, and that's a fundamental shift from the legacy world to manufacturing that's happening. I think it's shifting in days rather than months or years.
Wow. Now, if you look back at your trajectory of your career, can you see like, here's the direction and suddenly AI came and this is the direction? It just took a hard right kind of thing?
Yeah, if you call it as AI, probably yes. Few years back, we started using machine learning, AI, ML, etc. Right, and instead of just the rule-based algorithm that we used to develop, but Gen AI is just swept everybody off their feet. So even probably 2 weeks back, or January 10th is another landmark day with DeepSeek announcement. Nobody expected that coming our way on middle of January 24th or 25th, right? So that fundamentally shifted our approach again. So
that's incredible. So how do you see the convergence of AI and automation and digital twins like reshaping the entire manufacturing value chain?
Yeah. Okay. I'll probably, since I wear two hats, one the mobility and the connected plants or future of factory, I'll keep the conversation to the factory side of it, but there's a lot of resemblance to both sides, right? But why I say that is software defined factories is very similar to the approach that we have taken over the last several years on the software defined vehicle aspect of it. We are learning a lot from that aspect and applying to manufacturing, right? It's about abstracting the hardware from the software. That's essentially what we are trying to do, and digital twin or AI becomes part of that convergence, because the end goal for us is, how do I sensorize our plants? How do I create software defined factories, right? And to that extent, if we talk about that aspect, right, it's about how do I shift from very, very hardware centric manufacturing, where I'm very, very closely tied to the hardware of the plant or the systems in the PLC, control systems, etc., to managing it from a software perspective. And what it provides us is the agility and the responsiveness, right? So while manufacturing has always been about design anywhere, build anywhere, sell anywhere, right? From a global manufacturing perspective, it's easier said than done, right? Now with the convergence of AI coming in, convergence of digital twin, we can truly achieve this uh, X anywhere concept from that perspective, right? How do I create visibility in the supply chain from not only within my four walls of the plant, but to my supplier network or the customer network? And that's where I see this coming in. We talked about industry 3.0, industry 4.0 several years back. Now with industry 5.0 coming in, right, which is very, very, again, I would say back to the roots, human centric approach. So even with all this coming in, it's always human at the center. How do I weave automation? How do I help humans do things better, whether it's time to market, responding to demand volatility, anything from that matter, right? So that's how I see this convergence. It's always combinatorial. I cannot solve the problem only with the digital twin or only with Gen AI. It has to all come together.
So will these changes, these transformations to kind of software driven environments, is that going to change the geographic locations of manufacturing hubs and reshoring and nearshoring and all that? Will this impact the location of where manufacturing is done?
See, it should. At the end of the day, that's why while some people have talked about fully autonomous plant or lights out factory, we don't subscribe to that view from a TCS standpoint. We have an alternative which we will talk about in detail. But definitely, this level of automation will help us to nearshore manufacturing to a large extent, right? And it should be easy to replicate or manufacture closer to the customer, right? Obviously, there is a political dynamics aside, cost pressures aside, it this lets us move closer to the customer at the right manufacturing at the right place at the right time, right? So that's we should get to that point, definitely.
And there's probably all kinds of sustainability implications for being near to the customers.
Yes.
All kinds of things I can imagine there too.
Exactly.
Because of the flexibility of these environments, it might allow new kinds of business models, I would imagine. What do you think?
Yeah, definitely. The one of the key aspect of it is that manufacturers are sitting on a gold mine of data that they never had access to in the past from their own manufacturing or their supply chain. So we are typically looking to what we call as one servitization, right? How do I not make an asset heavy product? For example, even if you take a car or an industrial equipment, rather than just doing a one off sale to a customer that, okay, I sold a car today, an OEM doesn't know where the car lands after it has been shipped to a dealer, for example, or an equipment, once an industrial manufacturer gives it to a customer, they have no access to the data, right? But with this connected capability in a product, whether it's a car or an asset, how can I convert it from one time sale to a customer for life model, right? And that's an important aspect when it comes to data driven systems, for example, right? So essentially I can monetize my capability over the life of the asset rather than just sell and forget about it. And that's where everybody is going, any industrial asset, any manufacturing is going, right? How do I servitize? And with OTA coming in, right, over their updates, I can actually upgrade capabilities in a product after a physical asset has been sold. And that's a fundamental shift, right? You don't, like, even today we are talking about buying a new iPhone every 2 years. Can I have the same hardware in my hand but upgrade that capability over years? And we are not very far from that, right? In fact, there's a saying in the automotive from one of our leading industry customers that the today, if you ask me, the highest value that a car has is when you take it out of the dealership. After that, it starts depreciating, right? In future, you will see that is the time you take it out of a dealer is the lowest value of the car. After that, it will appreciate in value because you can upgrade capabilities.
I can appreciate that. I have a Jeep and I put a lot of added accessories on that Jeep.
Yep.
since I bought it.
Yes. Yeah,
And
exactly.
it's
So
probably worth more now with all those accessories than when I bought
exactly.
it.
But you're putting hardware accessories. So what if
Yes.
those accessories are software driven, right? That's where the value.
Yes. Very good. So, part of your area of responsibility is this factory of the future. Share with us some of that visioning out there. So, what does the factory of the future look like in terms of autonomy in the future here?
Yeah. So from a factory of the future, again, it's not something in the future. It's something that we want to help our customers get that vision into a reality, right? So what we have seen, obviously, manufacturing has been predominantly legacy in the American context, right? So there is a lot of brownfield and kind of legacy manufacturing, right? But if you want to look at from a factory of the future as a term, right, we believe in AI first manufacturing, which means not use AI as a band-aid on top of an existing setup and just say, okay, this is an AI use case, this is a Gen AI use case, but shift from reactive to an adaptive enterprise, right? That's what we want to get. Nobody is going to throw away billions of dollars of investments in legacy plants and set up new greenfield plants. Legacy plants are going to exist, right? How do I shift from them with the legacy plant, but with to an adaptive enterprise? We came up with a narrative called design for intelligence. That's the TCS go to market point of view, right, on how do I shift a customer from reactive to adaptive with this design for intelligence framework. And our end goal, like I said, our end goal is not lights out factory or autonomous factory, because with that you're achieving a goalpost. We believe that and we coined this term factories that grow, or plants that grow, right? With literally plants that blooms and leaves coming out, it's plant that grows. And which means that I'm always improving the KPIs in the plant, whether it's OEE or new product introduction timelines or the safety parameters, etc. How do I keep improving these metrics on a continuous basis through this through the introduction of capabilities that coming from our design for intelligence framework, right? That is our vision for a factory of the future, a factory that continues to evolve, that continues to adapt, that continues to grow. It's not about eliminating humans or having a lights out factory. That's the way we see it, and a lot of our customers are working with us today in kind of coming to this narrative that, okay, how do I embed humans and technology together and continue to evolve?
So, PLN, what are the dependencies that we're all waiting for that are still necessary to happen before many factories can advance to where their ambitions are?
See, definitely a couple of things. Where the core pillars that I would see in this is, say, the connectivity or the intelligent operations or the automation, right? Those three have to go together in terms of realizing this design for intelligence framework or an AI first manufacturing, right? To get to this, again, from a technology exists today, right? There is a lot of sensorization or IoT driven capabilities that needs to come in. There is a cloud component, there is an edge component, and there is a cybersecurity capabilities, right? So if without making additional investments, if I have to apply these technologies on top of this monolithic or proprietary PLC environment that exists today in the old legacy world, right? How do I ensure that I come up with these elements? We call it as smart nodes, which could be any of those, whether it's a product twin or asset twin, etc., all the way to predicting capabilities, digital twins, or the command center, etc. Right? There are about 8 or 9 categories that we have kind of built into our framework, and each of them has to evolve through a maturity model, right, to get to this stage. And each of these elements are driven by, like I said, connectivity, automation, cloud, cybersecurity elements. Those elements have to come together to achieve that.
So you must have these layers of acronyms, right?
Yes,
These
exactly.
frameworks, these methodologies that will support intelligence and support digital twins, support predictive and adaptive environments. Talk to us about some of those layers, some of those methodologies, some of those frameworks that you think are necessary to really help a company advance.
Again, on that topic, right? So, digital twin, like you brought it up, digital twin has been a term that has been there for years, right? The key challenge for us in a digital twin is most often than not, digital twin is only a twin at a point in time, right? But that doesn't add any value to us that, okay, I've created a digital twin of a process or an asset or a product or a plant in itself, as if it doesn't reflect the reality tomorrow, right? So it's very important to keep the digital twin in sync with the physical world for it to work effectively, right?
Mm-hmm.
And that's where these layers come in, right? If, for example, we talk about basic stuff, quality inspection in an assembly line, right?
Yep.
Quality inspection has been like a last line of defense when the product gets out of the end of that line. How can I create quality inspection as a fundamental element of manufacturing itself rather than as a process at the end of that line, right? There are technologies that's available today with computer vision capabilities, through edge compute capabilities, through self healing aspects that I can bring together to create this quality inspection, right? Then we talk about advanced AMRs in manufacturing, right? How can I have an AMR in a plant that can have a visibility to, say, the manufacturing sequencing, the inventory, the bottlenecks on the line, and can create what I call as self-optimized route optimization, where one AMR can talk to another AMR. It's like a fleet of cobots, right, managing the plant and interacting amongst themselves. And if there is a hazard in a route, it can actually go and uh, create a ticket for somebody to come and address it rather than just waiting there, for example, right? So those are capabilities that comes from a kind of automation that we bring to that plant, which coexists with other capabilities, what we call as virtual factory integration, right? Virtual factory integration is nothing but integrating these capabilities together in creating that. While industrial metaverse is probably a combination of asset twin, product twin, process twin, etc. It's the most strategic capability that you can get, and it's the most complex also, right? But I cannot be spending billions of dollars with a goalpost of creating a digital twin. I have to have an ROI in place, that and the ROI will come from individual capabilities, whether it's quality improvement, whether it's a safety use case, it could be an ergonomics use case, it could be a visibility use case, etc., right? That's how we bring these layers together into building that framework. So I'm not working on creating a digital twin in and itself, but digital twin as part of a system that helps me achieve and improve. That's why we say the focus is on improving KPIs, and focus is not in sensorizing my equipment. Focus is not on building an automation.
Right, because I can imagine that the advanced form or the mature form of this would be getting into an environment where it's about preventing disruptions,
Yes.
predicting things in advance so you
Yes.
can take action to avoid the disruptions. Is that the ultimate goal?
Yeah, definitely. For example, right, while we have all talked about uh, preventive activities, what if, for example, right, I'm a manufacturer, I don't know where my input material is coming from, a supplier at best, but if my supplier's supplier, like two nodes down, has a kind of a disruption, right? Either a Panama Canal issue or some strike at port in Los Angeles, for example, that happened. I wouldn't know at least another 3 months what's going to be my impact in my assembly line, right?
Mm-hmm.
What if using these capabilities of generative AI, etc., right? I can create those advanced risk assessment profile and create mitigation plans that, okay, because of this strike I am going to have a problem 3 months down that line because this is coming to a supplier from whom I'm buying my components, and create alternate paths, right? That's on the broader, slightly midterm supply chain visibility issue. But even in an assembly line, if I am going to have capacity issues, right, my demand is going up, but today, in the past, right, if I have to do a line layout, relaying out, or create a new relay than assembly line, it takes several months for manufacturing, engineering, safety, and production teams to work together to come up with a new layout. And you get probably a 2 week window without disrupting manufacturing to relay that line, right? And most often than not, you have a problem of making incorrect assumptions, and that during that period you run into crisis, you bought a wrong equipment that doesn't improve your efficiency, etc. Today we can do all this simulation even before making a dollar of investment, right? I can completely simulate along with you on a Zoom call, right, where I don't need to be an expert. I can use natural language process, right, commands that, okay, create me this layout, right? And with generative AI capabilities and visual rendering capabilities, you and me can virtually create a layout that works for us, complies to all our state and other requirements, the kind of equipment that I'm making, see what is my cost to make that changes, see are there any constraints that is there, right? So create it as all the OSHA compliance and everything, and you and me can simulate that, okay, if I need to increase my capacity further by 10%, what changes I have to make in this line. All that can be done in a virtual world before I even break ground or make a dollar of spending. That's the value that we are getting to.
And then the intelligent layer starts understanding everything that needs to be brought together to make a solid decision. They can then analyze what is the highest quality decision that could be made and what actions are necessary. It can probably just inform you. Yeah. Because you can start having that automated intelligent layer understand those things as well, couldn't you?
Correct. The automation or the generative AI, when it comes here, what it gives me is the next best action, right?
Yeah.
Which I don't know today, right? Because we're all dependent on the tacit knowledge of the workers that have been working or the managers who are managing them for the last several years. But we don't know what we don't know, right? The Gen AI can give us that next best action. How do I eliminate a bottleneck? How do I prevent certain things from happening? And this is, while it could be a decision support tool, it's kind of a glorified chatbot, but it can do much more than that, and creating those capabilities in our hands.
So as we start talking about more automation and robots and cobots and all of these kinds of things, it starts bringing up this topic of edge computing.
Correct.
Where you need to reduce the latency because you're in real time and moving environments, and you can't have big delays because there's people's lives that could be at stake from accidents and everything else. So you need to be pushing decision making, recognition, analytics, intelligence, pattern recognition out to the edges. Tell me about the role of edge computing in all of this.
See, yeah, Edge AI is a new term, and we have also started hearing physical AI, right? Which is pretty new from that perspective, right? So it's very important because both in manufacturing and mobility, we are talking about millisecond, nanosecond response times, right? You cannot, again, it's a lot more prevalent in autonomous vehicle, which I'm focusing on, right? If I have to drive a car autonomously, right? You don't wait for the car to see an obstacle, send that instruction to the cloud, and wait for feedback to come back. Those have to happen in nanoseconds, right? So that's where edge computing is very, very important. Also, if the in-vehicle experience that I talk about, if I'm wanting to use my cameras and all using my vehicles, if I have to just ask a question, can I park my car here? Right? Just there is a road sign and say it's in Chinese, for example. For all I know, I don't know what to do. Can I park here? That decision has to happen in quick. Otherwise, I will just cross that place, right? So that's where the edge compute comes from a mobility perspective. Even in manufacturing physical world, right? You need to stop a line. You need to take certain actions. That's where, and that's the component where IoT sensorization is very important, right? And we are talking about small footprint large language models, right? I don't need a very large 600 billion parameter model to run my plant. It's both compute intensive, and it's both cost and time consuming. So can I create small footprint model that is very, very tuned to my assembly line, very contextual to my plant? It knows everything from that, and that decision happens on the device.
Yes.
Right? So when we do virtualization, when we create that software layer on top of those legacy environments, these capabilities of edge compute can be brought into that line, and it can happen at that line. And we are very mature in that sense, right? We are all, while there is a lot of discussion about this LLMs that is there, right? And we can create for small footprint model that is custom designed for a particular use case in a plant. Whether, for example, we work with a customer where I get 7 seconds to decide whether a product is quality pass or quality fail, right? I'm just looking for defects through computer vision and certain capabilities. Yes. And the line is, and there are lines that are faster than this, but this example is very good in the sense that in 7 seconds, I need to say that, okay, this product is pass or fail, right? And that decision cannot be made somewhere else. It has to be made right then and there.
Mm. So those are applications that are very specifically focused on narrow areas, so narrow intelligence on those. But does the potential of AI, automation, all of this, does it have ways of making our senior executives better decision makers? Will it enable us to be more innovative in the future than we are now? Because perhaps they can think about many more things than we can if we're focused on just our machine in front of us. So, and even mass customization, where the same factory can be producing different products in the afternoon than it did in the morning.
Yeah.
Walk us through that. Where do you see at a big picture all of these AI and digital twins and automation? Where's that taking us?
So yeah, it definitely helps us shift from mass production to mass customization and also hyper personalization. Right? We keep talking about mass customization with a segment of one, right? Essentially, what you're saying, right? I can make your product, and the next product that follows that is a completely different product that I'm building, right? So it's possible. AI or Gen AI will help shift towards this hyper personalized processes, right? And it doesn't it helps us innovate because most of the work that we do are kind of shifted to from an automation capabilities, right? So that is definitely there, and it takes hyper personalization to a completely new level, right? And while there is always a discussion about what kind of jobs can get eliminated, but there are a lot of innovative jobs that will come along the way, right? Where humans are enabled by this technology. The potential, as far as I know, is limitless with this. The canvas is kind of very, very wide in that sense of what is possible. It's not only enabling managers, like you asked, right? How does it help? But from a decision making perspective, right? It helps improve efficiency. It helps improve throughput, right? It helps improve safety, for example, right, in the plant manufacturing, and getting closer manufacturing at the right optimal point. But yes, all with the end goal of how do I improve my KPIs? How do I create hyper personalized products for our customers? Right, that's definitely an opportunity with AI.
So PLN, where do you think, or how do you think traditional management structures and hierarchies, how do you anticipate these might in fact change over time because of these decision making and these instant action and in these expert focused systems? How's that going to change traditional management structures in factories?
Manufacturing is typically very slow in any disruptive changes, right? To a large extent, and that's going to continue, I would say. But yes, it's with the technology intervention, right? Today, it's a very, very siloed process when it comes to manufacturing. Whether even within a plant, there are siloed operations. But things like whether it's a digital twin or factory of the future will necessarily demand that these capabilities work together, right? Whether it's manufacturing, engineering, or I don't think anybody would talk about cybersecurity or cloud software within a plant, right? They think that is IT and I'm manufacturing. IT and manufacturing have to come together, work together in this world, right? What I say is, if you automate a wrong process, it will only do the wrong things faster, right? So you have to get the process right first, and then go and fix it. And to do that, right, so you need very innovative approaches, by definition, right? We have seen this in the automotive world. Software-defined vehicle cannot be built on top of legacy manufacturing approaches. It has, and we have seen success when technology is driven grounds up rather than top down. Same thing will apply when it comes to kind of shifting towards a software-defined factory or factory of the future, whatever we want to call it, right? So that structure has to change. People have to be adaptive to accommodate these changes that's happening from that perspective, whether it's IT or core manufacturing. We don't lose our focus on the uh, manufacturing or the technologies, the smart capabilities that we put into the product. Each of them is unique in itself and important in itself. But the structure has to change so that there's a lot more software and core manufacturing principles coming together. And it will take time. It's going to be a challenge, but it will take time.
So when we look at this vision and we consider this vision of the factory of the future, what are the obstacles that are preventing those dreams or visions from happening today? Is it people? Is it legacy investments? Is it just institutional, inertia? What are the obstacles preventing all of this from taking place right now?
It's all the above, for sure. All right. So definitely, like I said, the technology exists. Number one, to make this happen today, right? It's not the technology barrier; it's the adoption barrier that is where it's in the middle, right? And there is a reason to it. It's not by intention; it's the cost associated. People still don't see the ROI in this getting to this vision, right? If I'm spending hundreds and thousands of dollars to get a 2% improvement in my, say, capacity, for example, right? It's a difficult business case. So the coming up with the use case and the purpose why I need to go through this journey and what is it going to help me achieve at the end of it, right? And that's a strategic call that organizations have to make. And once there is a business case, probably things will line up, people's mindset will change, people, and then obviously then the investments will follow, right? But there's a lot of there's roots in legacy manufacturing that is kind of avoiding people to say that, okay, I can achieve this even without automation, right? But can I accelerate this with automation, right? Those are the things. So it's while it's all the above, while technology exists, I think for our job is to sell the ROI to our customers and saying that, okay, this is the reason and this is the ROI you will get by going through this. And that's been a hard sell, and that's something that probably organizations have to do better.
Well, I want to thank you very much, PLN, for joining us today, bringing your expertise and vision and sharing it with the team. Thank you.
Yep, thank you. Thanks, Kevin. I think it was a great conversation. Hope it was helpful.